1. Today we are going to look at solving differential equations using the method of separation of variables. Well, if we consider a differential equation, dy dx equal to fx out of g of y with the attached initial conditions. What we need to do is to make sure that we fully separate function of y of y and from a function of x. So we multiply both sides by g of y such that we have this, and then multiply both sides to x such that we have fx dx. So here we fully separate x variables from y variables. And then the next step is to integrate. Integrate after confirming fully that you have separated the variables. And when you integrate, you get the general solution, which involves the arbitrary constant. Step 3. Apply the initial conditions to get the particular solution. When you apply the initial conditions, you'll be able to get the value of the arbitrary constant, hence the particular solution. For example, we have dy dx equal to x out of 1 plus y squared. Where the first step, we're going to separate variables. If I multiply 1 plus y squared both sides, I have that. See? So I've multiplied this one both the sides. So it multiplies dy dx, and then x times dy times dx. Then after integrate, you have y plus y squared, y cubed out of 3, which is equal to x squared out of 2 plus arbitrary constant. This is now a general solution. It ceases from being a general solution after obtaining the arbitrary constant. The initial conditions say that when y is 1, x will be 0. So we substitute 1 plus a third equal to 0 plus c, meaning our c will be equal to 4 over 3. Substitute the arbitrary constant, substitute the constant back into the general solution such that we get the particular solution. Over 3, and that is our final solution. Okay, now let us try out this second example. As we said earlier on, we have to make sure that we separate the variables fully. So dy dx equal to x, you can separate it out factorize it out, and then separate variables to y. Separate variables, you can divide both sides by 1 plus y squared. So you do that, one will cancel, and then you have 1 plus y squared equal to x dx. At that point, we can now integrate. You can clearly observe the nature of this denominator, and it comes from the tan substitution. We can use the tan formula, the tangent substitution, and therefore obtain tan inverse of y equal to x squared out of 2 plus an arbitrary constant. The arbitrary constant, use the initial conditions from the question. When y is 1, x is 0. Substitute, we have tan inverse of 1, x is 0 plus c. Therefore, c is pi over 4. This is in radians, not degrees. So here I make sure that you write in radians. Okay, substitute back to get a particular solution, which is tan inverse of y, x squared out of 2 plus pi out of 4. So y will equal to tan x squared out of 2 plus pi out of 4. And that gives us the particular solution, the solution of the differential equation we had. So in the next video, we are going to look at a variety of methods of solving differential equations. Thank you very much.